Welcome to Time Value of Money Basic Concepts. My name is Craig Lemoyne, and we're going to be going through different functions of the calculator today. We're going to be going through different fundamental elements of the time value of money process. This is a great video to start with if you're just learning time value of money, or if you're just learning the HP 10B2 calculator. To start a discussion of time value of money, we really need to visualize the process. And so drawing a timeline is going to help you answer basic questions or more complicated questions as you go through the journey. If you look on the timeline, we've intentionally color-coded elements to match a little later in this video, but we start with present value. That's the amount of money that we have today. It's the amount of money we have in hand. Generally, present value as a variable is the amount of money you're investing if you're investing one time. That present value is going to be adjusted by an interest rate. And you can see the purple interest rate pointing to present value. Interest rate adjusts how present value grows every period. And so it might be growing every month or every quarter or every year, but that interest rate applied is generally stated annually and ensures that present value grows over time. Now, as we get more advanced, there could be an occasional situation where interest rate is negative, but for the most part, interest rate is going to be positive and help present value grow over time. And what does present value grow into? It grows into future value on the top of the timeline. Future value will be money in the future. If we invest today, what will we have in the future? We call that number future value. And the size of the future value is a product of, if we look under future value, number of periods, or N. So N is the number of period or number of payments that impact this timeline. So if it's 10 years for our money growing, N would be 10. If our money is compounding more frequently than annual, we would adjust N to the appropriate number. And lastly, that leaves payments. Now, some time value of money problems have payments, others do not have payments. But if we're going to be adding to that present value corpus or subtracting from that present value corpus on a regular annual series, we would call that a payment. Sometimes a payment will start at the end of a period, and sometimes a payment will start at the beginning of a period. But these are the key 5 elements in any time value of money problem. And in fact, when we now map that to our financial calculator, we can see that if you're looking at a 10B2, the top of the financial calculator matches to our timeline. So we see we have a variable key for N, and then on the timeline we have N as well. We have interest rate, IYR. We have present value, we have payment, and we have future value. And these 5 variables, if I give you 4 of these numbers, you will always be able to find the 5th. And so that's really the timeline. And I encourage you, as you go through any time value of money problem, to look at the timeline. Remember the timeline. Go ahead and draw it. Write the 4 variables you have. It'll make it a lot easier to solve for that 5th variable that you don't. If you want to break down the time value of money formula, and we're ignoring payments for just a moment to keep it simple, it's an algebraic relationship between the two. So how much money will I have in the future? Well, you take the present value you have today, you multiply that by 1 plus the interest rate accruing, and you raise that to the nth power, the number of periods that go by in order to get that answer. So FV equals PV times 1 plus I to the n. You can always find a 5th item if you have 4. And that's the magic of our financial calculator. That's the magic of using a spreadsheet or whatever tool you'd like to. If I give you 4 of these values, the 5th is going to be easy to find and rather straightforward on that end. So some basic concepts in time value of money, words that you're going to hear over and over again. The first word is opportunity cost. Opportunity cost is essentially, I can pick between projects, which one do I invest in? We deal with opportunity costs all the time. If you have an extra $100 at the end of the month, do you invest that in a savings account and make 1 or 2%? Do you take that $100 and invest it towards your retirement? Maybe you make 8 or 9%, but you can't spend it today and now it's locked up. Do you pay down a credit card debt with that $100, right? So as long as we have scarcity and finite resources, opportunity cost is a very real concept. And time value money helps us illustrate opportunity cost. Is it better to pay off a credit card or pay my mortgage? Well, we can run 2 different present value formulas and determine which one gives you the best bang for your buck. Interest is a concept in time value of money. We generally, looking down the road at interest, we're going to say interest is annual. And for most of what we're doing, we annualize an interest rate to make it easier for the client to understand. But interest might be compounding quarterly, monthly, daily. We have something called, continual interest when you look into finance. And so we use terms compounding and discounting to describe what happens to a dollar over time. When we grow the dollar into the future, we call that compounding, right? I invested $100 at 8%, it compounded into the future. When we're looking at a future value and pulling it backwards, when we're trying to solve for present value, we use the phrase discounting. So compounding interest moves forward on our timeline, and discounted interest moves backwards on our timeline. Okay, so compounding, we go to future value. Discounting, we find present value. No, those are really key concepts in the time value of money game. Before we do anything, let's set up the calculator. The first thing we always want to do is clear the memory. So we hit Shift and C for clear all. So Shift C, that's going to clear your equations. It's going to clear almost everything. It does not clear how many periods your calculator computes interest on, but it clears everything else. The next thing we want to do is set up how frequently our calculator compounds. So you can see 1, the Shift key, and PYR. What that does, 1 Shift PYR, is it tells our calculator, hey, let's compute interest 1 time per year. If you were to have hit 12 or 365, you would have told your calculator to compute interest more often. But 1 Shift PYR tells the calculator, hey, let's do interest once a year. Lastly, let's set our decimals to 4. Shift the equals key and the number 4 gets that job done. We always want to work in 4 decimal places so that our answers are consistent over time. At the end of the day, money rounds to pennies, but interest rates do not round to pennies. So 4 digits on an interest rate is going to get you close enough on most high-stakes exams to be able to pick the right answer. And that's why 4 is kind of a good number to use. You could use 6, you could use 8, but at that point, it's just extra typing. Shift equals 4 is the way to go.